Hello everyone, and welcome to Design Team 33's prototype proposal for the Most Beautiful Machine project, presented by Paul, Sai, Daniel, and Prod.
Our client, Team 32, had requested a robot that had basic movement features and one that could satisfy the following requirements. The robot must detect any object, wall, or corner within 1 foot of it. The robot then must evaluate its distance from the object, and it must move away from the object so that it is at least 1 foot away from it in its ending state. It must do this for every object that is less than 1 foot away from it. The system or functional block diagram for our robot is as follows. A user input starts the robot's starting mechanism and energy powers all of its systems. The starting mechanism then triggers the ultrasonic system, which then scouts the area for objects. The ultrasonic system outputs an object detection signal, which is then relayed to the motor system. Based on the proximity of the object, the ultrasonic system may send different messages to the motor system. If an object is less than a foot away, the ultrasonic system would send a move away signal, which instructs the motor to move the robot in the opposite direction of the object. Then, when the ultrasonic sensor measures the distance between the robot and the object to be greater than 1 foot, the ultrasonic system sends a rotation signal, which then instructs the motor system to rotate the robot in place in order to scan its surroundings and determine if the 1 foot distance criteria is met for any object in that robot's vicinity. The outputs of the motor system include a robot movement and heat created from the motors and the friction of the wheels on the ground.
We asked one significant question as a part of our design process, and that question was, will the object that the robot runs away from be anywhere around the robot or just directly in front of it? The answer to that question was, the object can be located anywhere around the robot, not just in front of it. Based on that, we created a needs finding chart to find our technical requirements. The customer need we had to address was to avoid the objects, and the technical need was to have a distance between the objects and the robot. And the technical requirement for this technical need was to move at least 1 foot away from all objects. And the target value was the same, to just keep a 1 foot distance or more from all the objects.
Right here, you can see our final design. We just have 3 pictures of it. The first one is kind of the front view. So you see the 2 front motors along with the ultrasonic sensor. You see the Pi and battery on top. Second is a top-down view. You can see where we place the Pi and how that's reinforced. You can also see the front 2 motors and the back 1 motor. You can also see that we had to take the rubber off of the back tires so that they didn't have a lot of friction and so that it could spin. Second is just a side view of it. That's the front, that's the back, kind of as we've talked about. That's the design. So some alternatives, we could have used treads instead of wheels. That way it could have turned easier. We opted to do wheels because having 2 treads would have required 4 motors. And we only had 3, of course, because that's how many came in the kit. So that's why we went forward with wheels. And then another alternative was to have more than 1 ultrasonic sensor. So for example, if you have like 4, you can have that ultrasonic sensor range all around. So that way they can detect, where the object is. Obviously, our limiting factor was the number of ultrasonic sensors. We only had 1 that we could work with. And so that's why we chose to just put it on the front and have it spin around. So next, we have a video. I'm just going to play it. So it placed about a foot away. You can see it spinning right now. It's going to detect it. There you go. And it's going to start backing up. And you can just see that when it senses an object that's about a foot away, it starts to back up, keeps spinning as soon as it gets out of range. And there's our presentation.